Oh, no, I never mentioned about the COVID virus, but I see it. Select a course, yeah, and then click on that college algebra course. Okay, so which one? Okay. Mm-hmm. Let's see so we can get into the problem, how hard it is to get from one to the next. Okay, what now? Uh-huh. Yep. Okay. Okay. That was fast. Went through. Hard drives were particularly prone to failing. And I was in a business where we sold historical data. And oh my God, I had some losses of hard drives that were just unbelievable. There's an OK down here. Should I? Yeah, I can click on that. No. Uh, um, in fact, I'll get out everything. Go ahead and see if your computer can get to your problems. And we'll see how far we can get with you verbalizing. And this way, you'll be putting it. Your computer may go slow also. I'm curious to see because you also have GoToMeeting running. Do I need to, did I log out of yours completely? Probably need to. Even if I'm out, I think I'm out. Yeah, I'm out. So you should be able to get it. Okay, good. What kind of stuff do we have? Is it stuff that we can you can verbalize? In fact, let me do this. Open page that I can write on a tablet. I'll wait till you get a problem. So. You're in slow also? Tell you what we might try, and that is close out Goto meeting and see if it speeds up your access to your page. And then if it does, log back in. Once you get the problems up, we might be able to get somewhere like that. Unless you want to just give it a little bit more time. Oh, okay, good, good. That actually is quite cumbersome. You can do it. The GoToMeeting allows for it. It depends on, let's find the very first problem, and it's probably going to be one that you can verbalize easier than flipping back and forth. In other words, for me to share, for you to be the presenter, I have to click like 3 things, and you have to click like 2 things. And then we're looking at your screen, which is okay, but then you can't see what I'm writing on my screen unless I click back on being the presenter. And toggling back and forth is so cumbersome that I've learned to just leave it all on my screen. Okay. Okay. Let's start with a problem. Okay. Okay. Define G of f of 5, like that. Goff. Okay. So the way you do these is you start from the inside. Okay. So let's find f of 5. What is f of 5 going to be equal to? Okay. So now what they're really saying is, what is g of 16? Do you have a calculator in front of you? You might need one. I've got one. I can do it for the moment. It's going to work better if you have one. But 16 times 16 equals 256 minus 48 equals 208 minus 4 equals 204. What I get? Go ahead and try putting that in, see if that's right. Yeah, that should be right. Okay, how about the next one? Okay. So start from where? What's the next thing? What's the next thing I should write? I want to find what? H of what? H of x cubed. In other words, h of x is x cubed. So instead of writing h of x in the parentheses, I'm going to write x cubed, like that. Okay? Now, what is h of x cubed? And the way you always do these is you take whatever's in the parentheses and you plug it in for x. In other words, it's x cubed, like that. With me? What is that? No, we don't add them. We are exponentiating, and the level that is one less exponentiation is multiplication. So we multiply them. So the answer is x to the 9th. You add them when you are multiplying the bases. You subtract them when you are dividing the bases. But when you are doing like a double exponentiation thing, like we're doing here, you multiply the exponents. Yeah. If you think of addition as being one level less than multiplication, and subtraction one level less than division, and multiplication is one level less than exponentiation. Okay? You can see everything I'm writing. Is that correct? Okay. Sometimes if I get close to the edge of the screen, students don't see it. So I want to make sure that's not happening. Okay. So again, what fog x means is f of g of x, like that. So start from the inside. Other way around. Start from the inside. Hold on. Hold on. Look, over here on the far left, I've got f of g of x. If we start from the inside, we're going to plug in what is g of x. So that's what we're trying to find, is f of root x. So if I go up here under the f function, f of root x, and now just plug everything in. What do you get? That's it. Yeah, unless they ask you to evaluate it at some x. If it was fog of 5 or fog of 6, then you'd plug 6 in for that. But if they want it as a function of x, then that's the answer, 9 root x plus 5. Just always go from the inside out. Okay, so let's start down here. G of f of x would be g of what? What goes in? Right. And now go to your g function and plug in. So it's g of 9x plus 5. So what's that equal to? That's it. Simplified. In other words, you can't simplify it any further. These are called composite functions, and we actually haven't been working with these lately. We've been doing the plus, the minus, the times, and the divide, but we haven't done the composite function. This is the first time we've worked with this under this new class here. I think we might have worked with them once before, but okay. F of g of x is this one right here, which was this, right? So what's the domain of that? Can it? No, the only thing that restricts the domain is that part right there. Everything's in the numerator, so we don't have to worry about dividing by 0. But radical signs restrict stuff also. If you're going to take the square root of something, it has to be greater than or equal to 0. So what does x have to be? No, forget the 5. 5 isn't affecting anything. Only thing you care about is square root of x. And to be able to do that, the domain of the square root of x is all positive numbers. X has to be greater than or equal to 0, which in interval notation is 0, bracket 0, comma, infinity. So that's the domain of fog x. Okay, g of f of x was this one, right? So what do we have to do to figure out that domain? Take whatever's inside the radical and do what with it? Set it greater than or equal to 0. It can be equal to 0, but the whole thing has to be 0 or higher. So if we solve that, we get what? 9x is greater than or equal to negative 5. X is greater than or equal to negative 5/9. And you know how to put that in interval notation. It's bracket minus 5/9, comma, infinity. And it's bracket because it's greater than or equal to. Yes, parentheses always around infinity. Okay. Okay. I'm going to write a little smaller. You can still read it, can't you? Okay, good. Okay. 8 inside or outside the radical? Like that? Okay? Okay. And fog of x means what? No, make sure you get your functions right. In other words, it really means this. That's what fog x means. So now, f of what? What's g of x? Okay. So how do we do that? Correct. And what's 8 minus x? What's the first part? Correct. What's that equal to? When you square something that has a radical sign over it, what are you doing? Okay. Which is 10 minus x. Okay, let me see. I'm going to write it really small here. So I'm going to write g of f of x, and I'm going to save a step by having you tell me what to put in that parentheses. Instead of f of x, I'm going to write what? It's f of x. There's f of x. There's g of x. Make sure you get them in the right order. In other words, f of x goes in the parentheses. Yeah, like that. Okay, and now what is g? Now you're done with the f function. Okay, you can kind of set it aside for a moment. Because all you have to do is this problem right there. So what's it equal to? And always use parentheses here, like that. Because otherwise you get the sign wrong in the 2. Okay. In other words, go ahead and simplify that by removing the parentheses inside the radical sign. No, it's still 8 minus x squared, but then it's minus 2. In other words, this minus sign has to be distributed to that term and also that term. So I get 8 minus x squared minus 2, which is 6 minus x squared, and that's your answer. And again, you can't really do anything with that in terms of simplifying it. 6 minus x squared. It's probably a little tricky, huh? No, I mean, it's probably a little tricky to input that answer because you got to hit radical sign and you got to hit 6 minus x and then you got to add an exponent to that. Right. So f of g of x was the bottom one, 10 minus x, correct? Now, if you looked at just the answer of f of g of x, you would say all real numbers for x. but the restriction actually comes from the individual functions. In other words, g of x is 8 minus x. That has a domain restriction in it. So you don't lose that domain restriction. So whatever the most restrictive domain restriction is going to be the domain restriction for your final composite function. By that I mean this g of x function, 8 minus x, what's the domain on that? So I said 8 minus x greater than or equal to 0, solve for x, lower left. -8. And now you got to divide both sides by -1, so you get x is less than or equal to 8. Yeah, the inequality sign. So there's your answer. That's the domain. So you're going to go from -infinity to 8 with a bracket after 8. And tell me when you get a right or a wrong on these, if you would. Okay, so let's talk about this concept here, because this is a little difficult concept. When you have composite functions, you can't just look at the final f of g of x to figure out the domain. Because like I said, if you look at that answer, it's 10 minus x, that's all real numbers. It does not have this restriction that x has to be less than or equal to 8. So with a composite function, whether it's the composite of 2 functions or 3 functions or 4 functions, it is always going to be restricted by the most restrictive domain of each individual function. Now the f function was all real numbers, so that wasn't a problem. But the g function is x has to be less than or equal to 8. So that domain restriction stays with you even when you've done a composite. And yeah, that one I do want you to put in and tell me if they say correct on that. Okay, because I always had a little problem with that when I was first learning it. That was difficult for me. The domain restriction. Okay, well, let's go back and do that the way you like to do it. Here, let me erase this down here. That's not normally the way you would have done it. You would have put the x on the right side, because you said that doesn't bother you. So let's do it that way. X is greater than, or 8 is greater than or equal to x. Now you don't have to switch anything. Now, how do you put that in? It's -infinity to 8. Same thing. So feel free to do it that way. That actually is a more efficient way to do it. Notice it was 2 less steps. I didn't have to divide by 1. I didn't have to switch the inequality sign. The only thing I had to figure out how to do is to take that answer and make sure I can put that in interval notation. No, personally, I like to, when I have an inequality, I want the x on the left side. But you are perfectly comfortable with it on the right side, and sometimes it's more efficient to put it on the right side, and that's a perfect example of where it should be on the right side. And that's the same function. In other words, the same 2 f and g functions. F and g functions, yeah. Okay, so Goff, we did that one, and we got square root of 6 minus x squared, right? So let's figure out that, because that's where we begin. What's the domain on that? On the final composite function? We'll start there. There wasn't any restrictions on the fog, but the Goff, there is, because there's a radical sign there. So how do I figure that out? 6 minus x squared has to be what? Set it greater than or equal to 0. It's an inequality. Okay? Now you move the x over there. Now, this is actually a little trickier. See if you can follow my reasoning here. If x squared has to be less than 6, then x has to be less than the square root of 6. That's definitely true. But also x can be greater. X can be, let's see, x can be less than or equal to negative square root of 6. Let's see, if x is, no, because that means it could be negative square root of 7, and that can't be. Yes, no, that does work. Both of these are your answers. Two different intervals. Go ahead and put in the answer, and I'll explain this a little bit easier where we don't have radical signs. This is a little tricky. When you have an inequality sign and you have the variable being squared, when you take the square root of it, you have to come up with both answers and switch the inequality sign. So you can see here that as long as x is less than square root of 6, then x squared is going to be less than 6, right? The negative square root of 6, not the square root of negative 6, but the negative square root of 6. Yes. Yeah. Notice that let's pick a number, see if that's correct. How about minus 10? Does minus 10 work? No, it doesn't. I got this backwards. Hold on a second. Just a second. Over here on the left. So, x has to be between let me just think about this before I say this. There we go. We know that it has to be less than square root of 6. But could it be negative 2? Yes, this is correct right here. So your interval is negative root 6 to positive root 6, both of them with brackets. It's negative root 6 to root 6 with brackets. In other words, like this. Negative root 6 to root 6. Yes or no? That work? Mm-hmm. Both with brackets. Yeah. The radical, yes. Okay, hold on a second. Before we go on, I want to explain that a little bit more. If x squared is greater than 4, then x, I take the square root of both sides, so x has to be greater than 2. That is certainly obvious, right? Also, x can be less than -2. Think of a number less than -2, like -3. Square it, you get 9. 9's greater than 4. So whenever you're solving an inequality where you have to take the square root of both sides, you've got one answer that's the greater than the positive number. You got another answer that's less than the negative number. It's a little tricky. So just remember that whenever you're solving an inequality by taking the square root, you have to allow for this possibility right there, all of them. And that's what we had. Only we had we had root 6 instead of a whole number, just to make it harder to understand and explain. Okay, what else you got? Okay. Okay. Tell you what, I'm going to make you the presenter. Let's see how hard this is to do. Sharing something else. They've changed this program. Okay, that's not what I want. Let's see. But it's giving you a lot of graphs. Oh. Okay. Okay, go ahead. Okay. I got it. Okay, so give me the f of x. Seven x squared. Is that correct? What I've written down there? Okay. So first of all, this is what kind of a function? What's it look like? Parabola. It's not a straight line when there's a squared in the x. That's a up and down parabola. Now, I don't know if it's there or there or there, but it would affect the symmetry of it. It turns out that let's divide by 5 and solve for y. So we have y equals 7/5 x squared minus 3/5, right? And that is a parabola at the origin. The 7/5 is just a stretch factor, making it skinnier. And the 3/5 is a vertical stretch. So I'm going to move the whole thing down to negative 3/5. And I'm going to draw it like this. Now tell me what kind of symmetry that is. With which axis? Correct. All parabolas that have their origin on the y-axis are going to be symmetrical about the y-axis. And this one does. Notice that if I had something like this, x minus 2 squared, that's not symmetrical. Because if I were to graph x minus 2 squared, I get the following. It's shifted to the right. I can hear you fine. Can you hear me? Yeah. notice that when I have a horizontal shift, I create a parabola that is not symmetrical with the y-axis. Okay, yeah, let me show you how to do. The origin is when you have an odd function. Okay, let me demonstrate. If f of x equals x squared, that's an even function. Even functions are always symmetrical about the y-axis. That is an even function. And the reason it's even is because the test is trying negative x. Okay, well, when I try negative x in there, I get the same thing. Okay? And when you get the same function, when you substitute negative x, that means it is even. If f of negative x equals f of x, which it does, in other words, this equals that, it's an even function, it is symmetrical about the y-axis. If f of minus x is equal to minus f of x, then it is odd. And odd functions are symmetrical about the origin. What would be an example of that? About if f of x was equal to x cubed. Well, what is first of all is determine whether it's odd or even by applying the minus x test. What's that equal to? That's always the test to determine whether it's even or odd, is to plug in minus x in place of x. Negative x cubed, which is negative f of x, right? So if f of negative x equals negative f of x, that's odd. And what does it look like? Well, we know this function. There is symmetry about the origin, and what symmetry about the origin is if you were to reflect the top half over the y-axis and then reflect it again over the x-axis, you would get this shape. In other words, if you take just that part right there, flip it over the y-axis, it becomes this, and then flip it over the x-axis, it becomes this. So this x cubed function is an odd function. It does have symmetry with the origin, and it's odd, and what's useful to remember is I use x cubed and x squared because x squared is an even function, even exponent. X cubed is an odd function, odd exponent. Now, that will frequently apply to polynomials, and then you'll get into trig, and trig has its odd and even functions also. Usually when you're talking about symmetry, that's what you're talking about, is the test of f of minus x. You always take a function, you plug in minus x, and you see what it's equal to. Is it equal to f of x, if it's equal to minus f of x, or it might be neither. If it's not equal to either f of x or minus f of x, then it's neither. There's only three conditions, three cases. Okay? All right, so let me erase this, and you give me your functions. We'll see whether they're even or odd. Oops, hold on a second. I keep thinking you're going to start out with f of x. 5x minus 5y. Go ahead. Okay. So if I take the y on the other side, switch them, I got y equal x, correct? Okay, another way of writing that is f of x instead of y equals x. Now what test am I going to do? How do I tell if this is an odd or an even function? Okay, what is f of minus x equal to? Okay, which is equal to minus f of x, correct? If f of x was x, then minus x is minus f of x. Since f, exactly, it's odd, that means it has symmetry over the origin. If it was equal to positive f of x, then it would be even. And if it's equal to neither, then it's neither. If it's not equal to positive f of x or negative f of x. Okay, you got another one? Or I erase? Okay, go ahead. Okay. So we're going to solve for y. So the first thing I'm going to do is divide everything by 7. Notice I have to do that first. And now I'm going to take the cube root. Well, I can take the cube root of anything. So y is going to be cube root of 2/7 x cubed plus 4/7. We're going to call that f of x instead of y. With me? Still there? Always. When you're checking symmetry, if you want to know whether a function is odd, even, or neither, the only test I know of is the minus x test. So let's plug that in. What do we get? Cube, correct, like that. Okay, now let's simplify that. Get the cube root of minus 2/7 x cubed. You see that? Well, that's true. Okay, plus 4/7, which is not equal to f of x, nor is it equal to negative f of x. It's not equal to one of those two things, and it's neither. Exactly. It might have some symmetry, but it's not about the y-axis or the origin. It could still have symmetry. If you take a parabola and you move it 3 units to the right, it has symmetry about the line x equal 3. That's a little different. It does ask about the x-axis. Most functions, so you put in neither. That's all they want. I'm not sure. This odd even really only applies to symmetry about the y-axis and symmetry about the origin. Because if I want to draw something, let me draw a parabola like that. Okay? That has symmetry. It doesn't really. No, sorry. Let me do something different here. Let's see. What would have symmetry about the x-axis? Whoops, I lost you. There you are.
Yeah, sorry, I don't know what happened there. I think the call just got dropped.
I'm hearing Can you hear me? Russell, can you hear me? I'm going to call you right back. No, can you hear me? Russell, let me call you back.
Can you hear me through the microphone?
I can hear you, but I don't think you can hear me. Can you hear me?
I can hear you through the microphone. I don't know why the microphone's not working and our phones aren't.
Yeah, that's good. We don't need the phone to work. This is much better audio, actually.
Yeah, it is.
Yeah. Okay, so I was trying to think of a function that is symmetrical about the x-axis. It's hard to think of one. The only thing I can think of is a circle, and that's not a function. Let's see. How about I'm hearing something else. Okay, let's not worry about x-axis symmetry. It really shouldn't come up. I'm not sure why they asked it, because you can't determine it with. Let's see. Would that be symmetrical? No. You know, there's not many things that would be symmetrical about the x-axis. That would be symmetrical, right?
Yeah.
What's the problem with that?
It's not a function.
Yeah, exactly.
So there really aren't any functions that are symmetrical.
That are symmetrical about the x-axis. I don't think so. Hold on one second. I think I got the TV behind me. No, my TV wasn't on. I was hearing other sounds. I don't know where they're coming from. Okay, so anyway, that's what else you got in the way of functions, because usually I've never heard of asking for symmetry about the x-axis along with the y and the origin.
Well, God only knows. They're probably just trying to trick me up in this class.
Yeah, I can't think of one that would be a function. It wouldn't be a function.
So the next question is asking if they're odd or even.
Okay.
So it's f of x equals x to the fourth minus 2x squared plus 8.
Okay. Apply the test.
So you just do the negative test. So it'd be negative x to the fourth minus.
Hold on. Make sure you use parentheses always on problems like that.
Okay. So then it would be minus a negative 2. Oh, okay, that's what you're doing.
Okay. Now what? Take the parentheses away. What do you get?
So it's x to the fourth plus 2x squared.
No, you got to do this part first. In other words, here's a case where both minus signs don't cancel one another because one of those minus signs is being squared. You are squaring negative x.
Exponents. So then it's just minus 2x squared plus 8.
And what is that equal to? F of x.
F of x. So this would be an even function.
Correct. In other words, if hold on. If f of minus x equals f of x, then it is even.
Okay.
That's how you test. It's going to be either, if f of x is going to be one of three things. It's either going to be f of x, which makes it even. It's going to be minus f of x, which makes it odd. Or it's going to be something else, which makes it neither.
Okay.
Okay.
And is it often true that even exponents creates an even
Yes.
function? And
Yes.
is that always true, or?
No, it's most of the times true.
Okay. Okay.
But when you're testing for odd symmetry, sometimes this will end up being a minus x. Okay? If I got an answer like that, that is neither f of x nor is it minus f of x. It'd be better if I can show it to you with a problem. Let's just keep doing problems and you'll see.
Okay. Okay. So same type of problem. So it's f of x equals x minus man, I'm trying to think of the name for that. I can't even come up with the name for that. It's the absolute value of x.
Like that?
Yep.
Okay. So tell me what that is.
So it's negative x minus the absolute value of negative x, which is x.
Correct. So this really becomes minus x minus the absolute value of x. In other words, this negative sign right there can always be taken out. Hold on a second. Let me think about this for a minute. Yeah, the absolute value of minus 3 is always 3. So,
yeah.
So this becomes minus x minus x. Hold on. Something I don't like about this. This is going to be a neither. I'm almost certain. Let's see. Can I put the absolute value back in there? I think I can. Let's just do that. Okay. I think that's correct. Now, is that either f of x or negative f of x?
No.
No. Negative, first of all, let's figure out what those would be. Negative f of x would be putting a minus sign in front of the whole thing. So you'd have minus x minus that, which would become minus x plus absolute value of x. So it's definitely not minus f of x. And it's not f of x. F of x is that. And this is not that. So this is neither even nor odd. Neither. Go ahead and verify that.
Yep, that's correct.
Okay. So absolute values tend to create neither. So that's one thing.
Okay.
But there's other polynomials that can be neither also. But the best way to explain them is to have one come up.
So the next question is f of x equals 2x root 8 minus x to the 4th.
Okay, when you have an x to an even exponent and you also have an x to an odd exponent, I'm guessing this is going to be neither. But until I apply this test, I really don't know. So tell me what this gives you. Might be.
So that would be, so it'd be negative 2x root 8 plus x to the fourth? No, minus x to the fourth.
First of all, yeah, always do this.
Minus, yeah, there you go.
And then minus x to the fourth is x to the fourth. So this is also equal to minus 2x times the square root of 8 minus x to the fourth. So what is this? Is that either f of x or negative f of x?
No. So it's a neat. It's
hold on. What would negative f of x look like? Up here on the top. You just put a minus sign in front of everything, right?
I guess you're right. I guess it would be it's an odd because it
is equal.
Okay.
To minus f of x.
F of x.
So it is an odd function.
That is correct. Yes, it is.
That's really what you do on all of these, is you plug it in, figure out what f of x is, figure out what minus f of x is, and if it's equal to one of those two things, you know it's either even or odd. If it's not equal to one of those two things, it's neither. It's really that straightforward. There's 4 steps.
Okay.
Every one.
So now we've switched from even or odd functions to transformations.
Okay.
But I feel like we're at 20 of 29, so we only have 10 problems to complete. Do you just want to start this up again next time?
Sure. I tell you what, the beauty of online is I don't have anything else scheduled tonight. You want to take an hour or 2 break? We can come back at it.
I actually have a couple things to do tonight, so maybe again tomorrow or something. I'm not sure if I'll have work yet due to the snow, but I do like this online.
Yeah, I thought you would. Most people do. You don't really lose anything.
Yeah, it's not ideal, but it's certainly not. I thought it was going to be way worse. Let me just put it that way.
It really isn't. And I tell you what, the beauty of it is that I've recorded it. So you will get a file of this session that you can review at your leisure. If you forgot how you determine whether something's odd or even, you can skip through the file to the last 10 minutes of our session and just review it. So there really are some advantages to it.
And I also feel like this is a lot easier with my work schedule. I'll be able to just come home and do a quick online session. And then
that's its biggest advantage is schedule.
Yeah.
Even though I'm pretty wide open, and that's not a problem for me, but a lot of times it would be. Where, you know, I would have certain windows open and you have windows open, and boy, it's hard to get them to overlap. But the easiest way is the online to work in a session there. And half-hour sessions you can do also. The next time you schedule it, probably schedule it for an hour, just because we generally take at least an hour.
Yeah, I just wanted to do a half hour because I wasn't exactly sure how it worked. We obviously went for an hour today.
Yeah, that's absolutely fine. The only danger is somebody else could come in and schedule right after you. So
that's true.
Go ahead and do an hour or even an hour and a half, which is fine with me, although it doesn't give you that option. You could do 2 of them back to back, one for an hour, one for a half hour. You don't need to worry about that, at least not yet. If I start getting swamped with online students, I'll let you know. But schedule it for an hour. That's probably the safest thing.
All right. Well, I will see if I can schedule one either tomorrow or Friday. But I really would like to keep at least an hour session on Sunday, just so I can make sure I get my quizzes down in the time limit and
let me go in and put it on there. In other words, I can schedule it actually easier than you can.
Okay.
Let me just make sure I tell me when on Sunday.
Honestly, anytime on Sunday, preferably afternoon, maybe like 2 o'clock.
Okay, I'll put you down on Sunday. We can make that regular if you want.
If you want to do that, that would be great. We just do an in-person session every Sunday, and then we do online
Yeah, and if you
throughout the week.
whenever you can schedule it, yeah. And if this doesn't, if you come across a Sunday where you can't do it, just let me know in advance, and I will take care of it. Hold on a second. Okay, so you're going to be scheduled, and I'm going to go ahead and make this for the rest of the school year. In other words, I can do that. You can't, but it lets me schedule every Sunday at 2 o'clock, make it a recurring appointment. And I'm going to do this every week. Hold on. Hold on just a second. I'm going to do this weekly until, well, I'll just go out a couple of months for now. I can always change that date. Okay, so you're in there at 2 o'clock every Sunday.
Yeah.
And then,
Perfect.
And then you can schedule anything other than that whenever you like.
Sweet. That sounds perfect to me. So I will see you. Hopefully, I'll talk to you before Sunday, and if not, I will see you on Sunday.
Oh, okay. So let me make sure I got everything right. This is Wednesday. We just finished this session. Our next session is going to be Sunday unless you schedule something on tomorrow, Friday, or Saturday.
Yep, that sounds right to me.
Okay.
Awesome. And then, so I'm not sure, is your online rate the same as your in-person rate?
Yeah, it's still 28.
Okay.
Yeah, if my in-person rate is higher if I have to go out. In other words,
Oh,
if I have to come to a student, it goes up to 40 or 35 rather.
okay.
But if a student's coming to me or if it's online, it's 28 per hour.
Okay, perfect. Awesome. Well, thank you so much, David. I really appreciate it. And yeah, we'll see you again shortly.
I'm glad we got this worked out. So.
Yeah, me too.
Okay, and let's see. You put your email address on these correctly. You're Russ. Yeah, you got it on there.
Yep.
When this file gets processed, I will send you a link to it. It'll be a YouTube link. And if you just click on that link, you'll be able to review the file. You'll be able to pause, fast forward, reverse. Works pretty good.
Sweet.
Yeah. Okay. I'll talk to you next time, Russ.
Awesome. Thank you, David.
Bye-bye. Oh, to close out a Goto meeting, just click on the X in the upper right.
Upper right.
See that? Yeah. You may. I'm not sure if your Goto meeting panel gets minimized automatically or what. It almost seems like it does for a lot of my students. But see if you can find an X. If you can't find an X, try to open up that panel by hitting on the two arrows that are pointed, two little white arrows pointing at one another. You see that anywhere on anything?
I don't, but there is a leave the meeting button. Does
that's what you want to hit.
Awesome. Well, thank you, David. I will see you again shortly.
Okay. Bye-bye.
Bye.